An airline's public relations department says that the airline rarely loses passengers' luggage. It further claims that on those occasions when luggage is lost, 90% are recovered and delivered to the owner within 24 hours. A consumer group who surveyed many air travelers found that 103 of 122 people who lost luggage on that airline were reunited with the missing items by the next day. Now, does this cast doubt on the airline's claim? Well, can we always start off with the assumptions or the conditions? So, first off, independence. It isn't really stated whether randomness is whether you have independence. There's no mention of random samples in this case. So there's kind of a question mark for these results. As far as the sample size goes, we have 103 were reunited with their luggage the next day. That means 19 were not. We have at least 10 of each. So sample size seems to be good. Independence is iffy. So anyway, for this hypothesis test, we're testing whether the proportion is equal to 90% or not equal to 90%. And the point estimate we were given as 103 out of 122. That comes out to be 84%. Standard error, we do the square root of the point estimate, so 0.844 times 1 minus 0.844, so 0.156, divided by 122. And it gets to be a standard error of about 0.0329. The test statistic is going to be the point estimate minus the null value over the standard error. So parentheses 0.844 minus the null value of 0.9 divided by the standard error of 0.0329. And we get a test statistic of negative 1.702. Negative just means that our point estimate was less than a null value. The p-value would be the normal CDF. Get rid of the negative sign, so just go with positive 1.702. The 999, 0, 1. 0 for the mean, 1 for the standard deviation. Paste times 2. And our p-value, 0.0888. That's more than 5%, so we should fail to reject the null hypothesis. So we don't have any evidence that 90% of the passengers are not reunited. The proportion may be less than 90%, maybe higher, but we don't have any evidence that it's different than 90%. Okay. Another question. What proportion of the American public approves of the job the Supreme Court is doing? According to New York Times CBS News poll in June 2016, only 47% of the American public approved of the job of the Supreme Court. This poll included responses of 976 adults. So, from this report here, the point estimate is 0.47. Sample size was 976. So, if I want to estimate the standard error, I go square root of 0.47 times 1 minus 0.47, so times 0.53 divided by 976. Okay. And I get 0.0160. Now, suppose I want to construct a confidence interval, 90% confidence interval for the result for the proportion of Americans who approve of the job the Supreme Court is doing. Recall that the confidence intervals are in the form of a point estimate plus or minus the z-score times standard error. And for a 90% confidence, we'd want to use z-star equals 1.64. So put in that information, point estimate plus or minus z-star times standard error. I would have 0.47 plus or minus, so 0.47 plus 1.64 times 0.0160. And then 0.47 minus 1.64 times 0.016. And you can see that the 90% confidence interval is from 0.44 to 0.496. Notably, I noticed that my high end is still less than 50%. So this would be evidence that less than 50% of the public approves of the job the Supreme Court is doing. So we are 90% confident that between 44.4% and 49.6% of the American public approves of the jobs the Supreme Court is doing. So the margin of error. Margin of error is basically the constant coefficient times the standard error. So in this case, 1.64 times that 0.0160. So the margin of error is 1.64 times the 0.0160. Margin of error comes out to be 0.02624. So what does that mean? It's a measure of how much difference we can expect between the point estimate and the actual value. So at that 90% confidence, this is what we can expect. If you want to be more confident, like say 95% confident, you would want to have a bigger net. So you'd want to have a wider confidence interval. So to be more confident, you need a wider net. Well, let's compute a 95% confidence interval. So for 95% confidence, we would use the z-star of 1.96. So confidence interval, 95% confidence interval, would be 0.47 plus or minus 1.96 times 0.016. And you can put that in your calculator, but it comes out to be about 43.9% to 50.1%. So we are 95% confident that between 43.9% and 50.1% of the American public approves of the job the Supreme Court is doing. So, is it plausible that a majority of the American public approves? Well, my 95% confidence interval does go above 50%. So, it is plausible that more than 50% approves of the job. At the 95% confidence interval, 51.1% is a plausible value.